Hi, in this video, let's talk a little bit more about the privacy extension for SLAAC. So in the previous video, we just talked about whether it uses EUI64 or a randomized identifier. So let's continue that conversation. Okay, so some have concerns, and rightly so, about an interface ID that can be directly associated with a physical device, the Ethernet NIC. That never changes. So, matter of fact, it would become very easy to correlate the same address to wherever you are. It doesn't matter what network you belong to. And so it doesn't matter, you can be on different applications, different websites, or whatever on the network, but you can relate all of that based on just the interface ID if you're using EUI64. Okay. Matter of fact, RFC 4941 actually gives an example of this and the concern for this. Okay, so let's talk a little bit then about how operating systems can use a privacy extension, a randomized identifier, and some other information to give ourselves a little bit more privacy with IPv6. And as you will see, more than with IPv4. Okay, so this RFC 4941, okay, addressed some concerns. First of all, what they say is that we can use a randomized identifier. Okay, so we talked about that already. Instead of using EUI64, okay, we use a randomized identifier. Okay, so we get the prefix from the router advertisement, the A flag set to 1, so we're creating our own interface ID, and we're using a randomized number. Okay, so this will allow us to create an interface ID that is not traceable. The other part of this, which is really cool, is something that we mentioned just briefly before, and that's the generation of a temporary address. So what does this provide? This provides for addresses that have relatively short lifetimes. Okay? This is actually an address that will be used as the source address whenever the device is originating a connection. So let me talk a little bit about this. So this device, let's say WinPC here, is going to end up with two addresses. Okay? It's going to have both an IPv6 address, okay, the public address, and it does have a randomized identifier, okay? But it's also going to have a temporary address, okay? Also with a randomized identifier, two different addresses, okay? This address will stay with the device. So anytime, it has a certain lifetime, we'll talk more about that later, but this allows for any devices wishing to connect with with WinPC, okay, it's going to use the public address because that's not going to change, at least during this connection period. However, WinPC, anytime it initiates a connection with another device, say a server over here or something here, it's going to use its temporary address. And that's going to be changing. We'll talk about the timers for all this in an upcoming video here for this chapter. But this is going to has a relatively short lifetime. That way, this is always changing, and it makes it more difficult for somebody to track you, even within just going from one web browser session to another. Okay? Makes it a lot more difficult, because that address is always changing. So it gives you a lot more privacy. Pretty cool. Okay, so implementing the SLAAC privacy extensions, okay, we see that the public address that I mentioned has a randomized identifier, and so does the temporary address. A temporary address can only have a randomized identifier. So it is possible that you can change this to EUI64 and have a temporary address, but it must use a randomized identifier. Okay. So we saw that in the previous video on how on the Windows PC, we changed the randomized identifier to EUI64, but we noticed that the temporary address still used a random 64-bit value. Okay. So here's the default. We can see here with our netsh command that this is the default that uses randomized identifier. Okay, so that's why here we can see we have randomized identifiers for both the global unicast address and the link local address. And whoops, went too fast. And remember, temporary address can only have a randomized identifier. Okay, here we've got by default, the privacy state is enabled. So set privacy state enabled. Okay, this is actually what creates the temporary address by default in Windows. And again, it can only have a randomized interface ID in blue here. Okay, so that's the default for Windows. Okay, we can disable that. If I disable the temporary address in Windows, so I set privacy state disabled, notice that there's no longer a temporary address. But because we did not disable the randomized identifier, the public IPv6 address and the link local address are still using randomized identifiers. All right, so hopefully that gives you a little bit of explanation. Remember, we have kind of two parts here. Let me kind of back up here that we need to consider. Okay, we have kind of two parts to all of this. We have, first of all, SLAAC, the prefix is being advertised and the A flag is set to 1. Okay, but the privacy extension really gives us a couple of different things. First of all, a randomized identifier for our public address, and also a temporary address, randomized identifier. Okay, if we can always change this to EUI64, okay, but we cannot change the temporary address. It can only use a randomized identifier. And again, just a quick review here. The difference of these addresses is that the public address is used for devices wanting to communicate with us, because that's not going to change. And the temporary address is for us communicating or initiating the communications with another device. And that we want to change. Yeah, because whenever we're establishing a connection, we want this to change because you know, we don't want to be able to be tracked. All right, kind of gives us a little bit more privacy. Okay, well, I hope that helps explain a little bit about the privacy extension. Again, a lot of cool things in IPv6.